which is good. But you'll have digital input, digital output, analog input, analog output, right? These are function calls that you put into your C++ program. You call it a sketch, but it's a C++ program, and it makes those function calls to those routines. Those are really easy to do on microcontrollers. The big difference when you get up to a Linux operating system world is you have a device driver model and device abstractions. So everything goes away from a function call and is now a file. So my LEDs, rather than have digital read and write, yeah. So I think those are the functions. Not digital input and output, it's digital read, digital write. Instead of doing those, you just say, okay, I've got these files. So I'm going to change directory into sys class LEDs, and I'm going to mess with the red LED because it's nice and bright, right? So I did another directory listing, and it shows me a bunch of different files.
You have a file called red?
I have a file called red. That's for the red LED.
Whoa. So when you update that file, that's when the microcontroller grabs the information from there and then
it's more fun than that. So cat is a way to read the contents of a file and dump it into standard out. So I wanted to make sure you guys understood the concept of streams, which is standard in and standard out. So if I have a file, I have a way I can direct output into a file or read output from a file, right? From any programming language or even from the bash command line, right? So cat reads the contents of a file and dumps it to standard out, which is the terminal, right? So I've just opened to the file trigger, read its contents, and dumped it out through the terminal window. And this is not a real file, right? This is actually talking to code on the other side. So with the device driver abstraction, there's essentially, I called the function in the operating system called read. Well, it goes to the device driver and calls the read function in that driver, and then it decides what it's going to provide back as data to the read function. In this case, it decided, oh, if you want to read trigger, why are you reading trigger? Well, it decided that what you want to know is what triggers are available. And so here's the list of triggers. So there's a nice one called, let's use default on, default-on. So I'm going to do echo default-on. This greater than is not an argument. This is something interpreted by bash to tell it to do something different with the standard output of this program, right? The program running is echo. This argument is a string of what I want to write. The greater than sign says redirect the output instead of just having it spit it out to the terminal, right? If I don't put the greater than sign, it just spits it out to the terminal. By doing a greater than sign, it's going to try to put it somewhere. Now I tell it where, the file name trigger. Okay? Press enter, red LED is on. Everybody able to turn on the red LED?
Yeah.
Red LED on. Now if I cat trigger, you see this square brackets, right? It's going to tell me what the active trigger is as well by square brackets. It could just tell me, default on. That's would probably be a typical way to do it, to just say what the current trigger is. But it's far more informative for it to list off all the possible triggers. And you can add more triggers to the operating system. Like the Wi-Fi device has this one called Phi0 association. So just say it's associated with an access point. So you'll see there's a Wi-Fi LED. And by default, it should be configured as Phi0 association. So if you don't see the Wi-Fi LED on your board, if it's not turned on, it's because you haven't connected to an access point. Right? So there's two dependencies there, right? There's the connecting to the access point, and then there's the configuration that the kernel says that that LED's trigger is to tell it to turn on when it's connected to an access point.
So
Because I can change it. I can go default on. And now my, oh, I didn't change, oh, not cat, echo. Sorry. Now my Wi-Fi LED is on. Right?
So if that trigger changes in the file, then when does the light turn on?
Well, it turns on based on what the trigger is.
And so when
So I could set like a GPIO trigger. So I could set the LED to come on based on a GPIO input.
but the processor is checking the input, so it's comparing something and then activating, right?
Well, it's setting a mode of the LED driver. So the LED driver has different ways that it can decide it wants to turn on the LED. This list of triggers are the different, essentially, programs that are sort of built into the kernel to decide when to turn the LED on. The default on trigger says just turn it on.
Does it take a clock cycle or more or less to execute
Many more than a clock cycle to execute.
So it's always buzzing, it's always checking, and it's always outputting.
Yeah, so there's different process threads within the kernel, and as they get scheduled.
So that's scheduled by whoever wrote the kernel.
Right. There's like it's scheduled by whoever wrote the kernel driver. So like there's this one called timer. Like let's echo timer into trigger. Now, if I list, there's these other parameters now that just show up in the directory. There's delay on and delay off. All right, so you'll see my LED blinking. All right, I did this on the Wi-Fi LED. It's just kind of blinking. If I read the content of delay on and delay off, those are in milliseconds. So I've got where in the presentation I've got the I've kind of jumped ahead, but in Linux everything is a file, right? So we kind of understand boot, I hope, mostly now, but.
Is there a limit to the amount of people that you can have connected to a single Beagle over Wi-Fi before it start getting a lot of issues or anything?
There is.
Because we're both connected to the Beagle over 5.0.
It's probably going to be. I mean, it's going to be more than 5 or 6.
Okay.
It's probably in the order of dozens.
Okay.
There are resources utilized by other people connecting, but they're not tremendous.
Okay.
Can you split the Cloud 9 so that two people can use separate Cloud 9 sessions on the same device?
Generally, if you want to use, you could both use the same instance at the same time and be editing different files. You'll share terminal views, but you can be editing different files.
So if two people are using terminal, then just open up the terminal tabs.
I believe that's the way it works. If you're not looking at the same tab, you just won't have the content synchronized.
Okay.
So if you're on the same tab, your terminals will stay in lockstep. If you're on the same file, as long as you stay off of the same file and stay off the same terminal, you shouldn't have conflicts.
And where is
And
it?
also, so everything in the trigger file is,
Separating out.
so there, I mean, 'cause it's not only default on that trigger
So
file.
default
Right.
file is already written. So you're not writing it, you're assigning.
So this stuff is documented as far as what the triggers are and
assigning
what
that
the.
to trigger.
I really wasn't meaning to dive into LEDs. I was trying to make sure we understood redirection, so that you kind of understood the basic bash command prompt. I was using the LEDs as an example, But really everything, all the I/O stuff coming from Linux kind of works that way. Their kernel documentation has the sysfs ABI, or application binary interface, that describes what the different interfaces are. So for the LED class, right, and you've got all these different triggers. If you go to this, there's the list of all the other different types of triggers and what their different modes are. So it's all kind of listed in these. Let me visit the site and show you. All right, so there's max brightness, there's triggers, but if you go and look in this directory, there's one-shot triggers, USB port triggers. All right. Not everybody is perfect at documenting, so that can be an issue, but in general, that's the way that's set up.
So,
You joining the workshop?
Yes.
I guess
What's your name?
there's
Michael. David.
say
Are you in the capstone?
activity. If I, well, I guess it's kind of hard for me to make an example of what that means.
Just don't trip over the camera.
But if, say like if there was a disk, right, there's disk activity.
Disk activity, right? So by default, we've got five different triggers kind of set up by default. There's a heartbeat trigger on user 0, so you should see this nice friendly thump, 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 thump on the user 0 LED. The user 1 LED is set up for SD card access triggers, and the user 3 LED is set up for eMMC triggers. So any eMMC writes should blink user 3, and user LED 2 should be set up for CPU activity. So those are the defaults, and then the Wi-Fi LED is set up for an association, so when you're connected to a hotspot.
So I should be able to turn on any one of those. So for any LED, I can turn on, say, disk activity, and now that LED is showing disk activity stuff.
Exactly. And now, if you want to change that on boot up, without having, like, you could do it in if you did a shell script that just wrote it to have it do that on startup, that's one way to change it. These are initially defined in that device tree.
Okay.
So there's if you look at the device tree, the boot up configurations for each of those LEDs is a parameter configured in the device tree.
What's the path device tree?
The source or the actual file. So
The actual file.
So let's go back to this boot diagram. Which one?
He's got the whiteboard marker.
So there's a couple of directories on the board, and maybe we're at this point because what we're working towards now is actually writing the SD card with the contents of our boards, and then we're going to want to flash it back again, right? So we're going to try to cover the topics necessary to get to that. So one of those things is kind of understanding a little extra part of this boot configuration. So in the /boot directory, the bootloader comes and reads this file called uenv.txt. I'm going to show you a kind of a wonky trick here. I mentioned that everything showing up in this directory view is coming from the Cloud9 varlib Cloud9 folder. I'm going to create what's called a symbolic link to /boot, and now boot shows up here. Total hack, right? So now the contents of the boot folder show up under varlib Cloud9, and you'll see this uenv.txt file. First line kind of shows where the maintainer, Robert Nelson, has the documentation for it. If there's any documentation bugs, let's try to make sure that he gets those incorporated into that file location. But there's a few different things. This uname_r, that's the revision of of kernel that we want to run, right? So one of the commands you can run in Linux is this thing called uname. And it says on Linux, that's not very informative. There's uname-a, and it gives the full description of the Linux that we're running. So Linux on hostname Beaglebone, kernel version 4.19.50. It's on his TI branch, that's Robert Nelson's TI branch, and then release number 20. This is running Debian Buster today, that's Debian 10, which just got released, I think a week ago or so. It's a fairly new version of Debian. SMP is symmetric multiprocessing with a preempt kernel, and then the date that it was built and some other stuff like that. But